It has been quite a while since I worked on this project. I think it's over a year now that I last took this out of the box and actually did some work on it. Last video is definitely longer than a year ago. But I finally built the kit, I put it all together, and it actually looks rather nice, except for the tube sockets that I completely and utterly butchered by putting in ones that are supposed to screw down to the chassis when it should have like print sockets. Well, anyway, I'm probably going to change that later, but it works perfectly well. It's a very good kit, and it sounds very nice. So I had this powered up on the lab power supply. This doesn't have a power supply attached to it yet. But the important thing is I finally decided on using PCC 88s. This is actually not recommended, but the spec sheet gives you the choice of the ECC 88, which is very similar to this. It just has a different heater. So yeah, it's probably be fine because it's the same valve. It just has a different heater. It has a 300 milliamp series string, and so I had to redesign my power supply for the filaments. So this video is going to be titled Building a Better Filament Power Supply. And I actually did it on some prototyping board because I couldn't be bothered to etch a circuit board for such a simple circuit. And actually it looks really nice, and I put down this heatsink that I also screwed to the board so it doesn't fly away. And this is just based on a transformer, capacitor here, big filter cap, bridge rectifier, and an LM317 with two resistors. But those are not, as usual, there to set voltage. Instead, they're there to set current. And I'll draw the schematic up here real quick. The circuit for this looks like this. We have our line voltage coming in through the transformer, which is a 24 volt transformer. Just a small 24 volt transformer. It will be alright. I rated it, so it's just about enough. Through a bridge rectifier, this going to ground, this going to a filter capacitor, which is 1000 microfarad in my case. I might make that larger if it should cause any problem. It can be quite a bit larger. It's actually good practice to use a bit of a larger capacitor, but I think this will suffice. And then it goes into the LM317 with the input pin here, the adjust here, and the out to this side. And we have a 4.3 ohm resistor here, which ties back to adjust, and from there we go to the filaments, and this goes to ground. What this does is basically the LM317 keeps 1.25 volts over this resistor, towards the adjust pin, and that results in roughly 290 milliamps flowing through here, which is just about within the spec of the tubes. So this should be fine. And I'll just bring this over here again. One other thing to note that's actually somewhat important. If you do 230 volts on prototyping board like this, it's a good idea to just grind away the copper here. And also I still have to grind away the copper here so it doesn't arc over or do anything funny. This is actually somewhat important. And I also did it here, although it's not strictly necessary. So how you do this is you just take a Dremel with a little sanding wheel on there, and then you just more or less carefully grind away the copper. There's still a tiny bit left. It's actually somewhat hard to reach in there. So I'll just use a small diamond file to yeah, that's just about perfect now. So this doesn't have any chance of actually arcing over between the contacts, and that is important. You don't want that to happen. So we're just going to test this here now. Putting this on here and connecting the other lead here. I'll put the multimeter down here. It's on DC and amps. I'll switch on the power. And if we measure between ground and the actual adjust pin, we'll get 289 milliamps, which is perfectly adequate. We can also check if this is getting hot, which it is not. This is also good news, that the heatsink is about right. What you actually can see is it goes down a little bit as the components heat up, especially the resistors are probably getting quite hot. I have to test if this is actually a problem, but it is actually a very extreme situation because I'm basically pumping 20 volts into the LM317 because the multimeter is basically a dead short across it. So to keep the current at 300 milliamps, the LM317 has to dissipate most of the voltage. So this is actually getting somewhat hot now. Yeah, the resistor is also somewhat hot, but yeah, it's still all right. This should work perfectly with the amplifier. So, but I'll still have to measure that eventually. I also put it on some standoffs so it can fit snugly in the case. That are also redesigned, but this will be subject of the next video.